This lecture introduces you to the aggregate expenditures model. The famous economist John Maynard Keynes developed the aggregate expenditures model to explain the Great Depression of 1929. The model explains why the business cycle occurs and helps us understand what we can do about them. Before the aggregate expenditure model, there was no explanation for the business cycle. We will go ahead and define the purpose and the assumptions of the model. Before the Great Depression, the prevailing economic theory was based on the classical economic model of supply and demand, a theory according to which the market determines all economic outcomes. According to the classical supply and demand model, the market is always in equilibrium. In a shortage situation, the market equilibrium price rises to help eliminate the shortage. In a surplus situation, the market equilibrium price falls and helps eliminate the surplus, and the market moves to a new equilibrium. According to the classical model, the business cycle does not exist. During the Great Depression of 1929, the mechanisms of the market failed to correct the imbalances. This prompted some economists to inquire into the matter. Among the group of economists researching the issue was John Maynard Keynes. Keynes was a British economist, largely heralded as the father of modern macroeconomics. Time magazine lists him among the 100 most influential people of the 20th century. What are the assumptions of Keynesian economics? To understand Keynesian economics, we must refer to the circular flow model and understand the following. First, labor and production are determined by how much people spend. The size of the economy, or real GDP, depends on the total expenditures in that economy. Remember that in the circular flow model, the main assumption is that production and expenditures are, more or less, equal. If expenditures rise, factories and businesses hire more workers to produce more output. If expenditures fall, factories and businesses idle, or reduce hours, or lay off workers to produce less output. Keynes concluded that, the problem during the Great Depression was the inability of the economy to adjust output automatically, to match the current spending level. Some spending cannot adjust automatically in the economy. The solution Keynes offered was to increase the level of spending during recessions, and decrease it during inflations. As we explained with the circular flow model, the economy is in equilibrium when production, or output, is equal to expenditures. This happens because household incomes are used to purchase business-made goods and services. When reviewing the unit on the economy's health, we learned that GDP equals C, plus I, plus G, plus NX. Using the expenditure approach, this GDP formula assumes that the nation's output value equals the nation's expenditure level. The same formula is thus used to calculate the nation's aggregate expenditures. Aggregate expenditures equals C, plus I, plus G, plus NX. If any of the components of aggregate expenditures were to increase, the nation's output would have to increase to maintain the macroeconomic equilibrium. Firms would have to produce more, leading to increased employment, and the recession would be progressively eliminated. The scenario described above assumes the following: prices are fixed. Some expenditures in the economy are independent of the level of output, real GDP. It is important to understand how we use our income, to understand the effect of additional spending on the nation's output. This is why we need to explain the marginal propensities to consume and save. As this illustration shows, our income minus taxes is our disposable income. Our disposable income is either spent or saved. Marginal propensity to consume, MPC. The marginal propensity to consume is the fraction of our disposable income that we allocate to consumption expenditures. MPC equals change in C divided by change in Y. For example, if you earn an additional $500 at work and decide to take your friends to dinner and spend $100 out of the $500, the change in your disposable income is $500, and the change in your consumption expenditure is $100. Applying the formula, the marginal propensity to consume, MPC, is $100 divided by $500, and the answer is 0.2. So, MPC equals 0.2. Marginal propensity to save, MPS. The marginal propensity to save is the fraction of the additional dollar in income that is saved instead of being spent. Similar to our previous example, if you earn an additional $500 at work and decide to take your friends to dinner and spend $100 out of the $500, the change in your disposable income is $500, and the change in your saving is $500 minus $100, which equals $400. Applying the marginal propensity to save formula, MPS is $400 divided by $500, and the answer is 0.8. So, MPS equals 0.8. Since each additional dollar in income earned is either spent or saved, or as I would rather say, a fraction of the additional dollar is spent, and the remaining fraction is saved, MPC and MPS must add to 1. Consumption schedule. The consumption schedule is a graphical illustration of the relationship between our consumption expenditures and our disposable income. It is the first building block of our aggregate expenditure curve. The consumption schedule represents our consumption function and shows the positive relationship between income and consumption expenditures. As our income increases, so do our expenditures on goods and services. It is important to note that our consumption expenditures are never zero. We need to consume some goods and services to be able to live. Whether we have income or not, we still spend. The portion of our consumption expenditures that will always exist, even when our income is zero, is called the autonomous consumption expenditure. It is shown as the vertical intercept on the consumption expenditures graph. From this intercept, our expenditures rise as our disposable income rises. The consumption expenditures function is C equals C0 plus MPC times the disposable income. C0 is our autonomous consumption expenditure, the fraction of expenditure that always exists even when our income is zero. Equilibrium. Break-even point. Let's add a curve to our consumption expenditures graph. This curve is a diagonal 45-degree straight line from the origin, which divides the graph into two equal areas. The 45-degree line represents a situation where all the income earned is spent, and there is no saving. As your income rises, so does your spending, but in such a way that you always spend the entire added income. When this curve is overlaid on the effective real consumption expenditures curve, the original curve, there is an intersection between the curves at C1, D, I1. This intersection represents a break-even point. At this intersection, we spend all our earned income, and have no savings. On either side of this point, we could save, or borrow to fund our expenses. If we are on the right side of the curve, we save, because our earned income exceeds our expenses. If we are on the left of the intersection point, our earned income is less than our spending, and we borrow to fund our expenses. We call this dis-saving, or, using other people's savings. Saving in income. If we place the savings graph next to the consumption expenditures graph, we can see that the intersection, or, the break-even point, of the consumption schedule graph, corresponds to the point where our saving is zero, on the savings graph. Before the break-even point, our saving is negative, which represents dis-saving. After the break-even point, we have positive savings. The slope of the saving curve is the marginal propensity to save, MPS. Creating the aggregate expenditures curve, AE. The aggregate expenditures curve is constructed by adding the other components of AE to the consumption schedule. Recall that AE equals C plus I plus G plus NX. We must add I, G, and NX to C to obtain aggregate expenditures, AE. Investment schedule. Investment, I, mainly depends on the expected rate of returns of the project the investment funds are meant to finance, and the expected interest rate on the market. The expected rate of return represents the marginal benefit, and the real interest rate represents the marginal cost of the project. If the expected rate of return is greater than, or equal to, the real interest rate, businesses will borrow and invest. Otherwise, no investment will be made. The investment demand is thus inversely related to the interest rate, as shown in this graph. The higher the interest rate, the lower the quantity demanded of investment, and vice versa. Note that the income level in the economy is not a factor here. Moving from personal consumption expenditures to aggregate expenditures in the economy, we will use real GDP instead of disposable income, because real GDP represents aggregate incomes, or the value of the nation's output. Investment, government purchases, and net export schedules. Investment schedule, I. As we noted earlier, the investment schedule depends on net returns, not on national income, or output, real GDP. For this reason, the level of investment is assumed to not change as income, output, changes. The investment schedule is, therefore, a horizontal line at the quantity demanded of investment. Adding the investment schedule to the consumption schedule gives us, AE equals C plus I. Because, I, do not change with income, it will be added to C0, the autonomous consumption expenditures level. This will cause the intercept to shift up, by the amount of the investment expenditures. Government purchases, G. Government purchases are also independent of the nation's output. Government purchases are a budget voted on by Congress, state legislatures, and local government councils, and signed into law. For this reason, the government purchases schedule, G, is a horizontal line, representing a constant, since it is independent of the nation's output. Adding G to the aggregate expenditures curve shifts the aggregate expenditures curve by the government purchases amount.
Now, we have A, E, equals C, plus I, plus G.
Net export schedule. Net export, NX, is the difference between the value of the expenditures on imports and the value of our exported goods. The net export value largely depends on foreign incomes, over which we have little influence. We can safely postulate that next export should be constant, since its value does not depend on our national income. Adding net export to our aggregate expenditure schedule, as a constant, will only shift the curve up or down, as it only affects the level of autonomous expenditures. Now, our aggregate expenditures schedule is complete.
A, E, equals C, plus I, plus G, plus NX. Remember that I, G, and NX are all independent of the output, or national income.
The expenditures multiplier. The expenditures multiplier is the factor by which a dollar spent in the economy will generate in total output. Recall that Keynes advocated an increase in spending to help end recessions. It is the concept that an additional dollar spent results in more than a dollar worth of output. As we will see in the equilibrium dynamics section, spending just a little bit can help generate a larger amount of output. As seen on the graph, a relatively small change in aggregate expenditures leads to a larger change in output from YC to YC plus I. This is how it works. When one person receives income, they spend a portion of it. That spending becomes income for someone else. When the other person receives this income, they too spend a portion of it. This can, then, tell us how much the nation's output will eventually increase for any initial change in income. The spending multiplier is calculated using the marginal propensity to consume, MPC. The formula is, multiplier equals 1, divided by 1, minus MPC. If our MPC is 0.6, the spending multiplier will be 1, divided by 1, minus 0.6, which equals 2.5. With a multiplier of 2.5, each dollar spent in the economy generates $2.5 worth of output. The change in output is calculated as the multiplier times the change in aggregate expenditures, the tax multiplier. Another way to stimulate, or discourage, spending is to change taxes. We would have to calculate the tax multiplier to see the impact of such a policy. The tax multiplier is calculated as negative MPC, divided by 1 minus MPC. If our MPC is 0.6, the tax multiplier is negative 0.6 divided by 1 minus 0.6, which equals negative 1.5. If the government decreases taxes by $1, as in negative $1, it will generate an additional $1.50 worth of output, calculated as negative $1 times negative 1.5. Note that the tax multiplier has less effect on output than the spending multiplier. Equilibrium dynamics. Now that we have constructed our aggregate expenditures model graph, we can use it to analyze the economy. First, remember that our aggregate expenditures equals C, plus I, plus G, plus NX.
Also, increasing any spending category C, I, G, or even NX will increase the total aggregate expenditures in the economy.
Further, any such increase will more likely shift the aggregate expenditures curve upward. On the other hand, decreasing these expenditure categories will also decrease aggregate expenditures, which means shifting the curve downward. Look at our graph. The blue line represents the economy's combination of output and expenditure levels, where output equals total expenditures. It is a 45-degree line reminiscent of the line in the consumption schedule. On this line, total output equals total expenditures at any output level or expenditure. The curve will be called total production curve, or AE equals Y. There is an intersection point when the AE curve overlays the total production curve, AE equals Y. At this point, the current level of expenditures in the economy equals the current output level. We call this point a short-run equilibrium. The economy is always in some sort of short-run equilibrium. The question is whether this equilibrium is reached at the desired output level. To determine whether the economy's short-run equilibrium is desirable, we must compare the output level at this equilibrium point to the full employment output level, which is the desired output level. Let's say the current output level is $400 billion. Assuming the full employment output level is $500 billion, there is a gap of $100 billion. This gap represents how much output is not produced because the economy is in a recession. Keynes explains the recession as a spending shortage. To eliminate the output gap, we must increase spending in the economy.
An increase in C, I, G, or NX would push the AE curve upward, until the new AE curve crosses the 45-degree line, at the $500 billion output level.
It can be seen that only $50 billion in extra spending is needed to eliminate a $100 billion output gap in this economy. Why do we need less spending to eliminate a greater output gap? The answer to this question lies in the concept of spending multiplier. Identifying recessionary gaps. This graph represents our business cycle. We have learned that the business cycle has four main phases: the peak, the recession, the through, and the expansion. How are these phases mapped with the AE model? This graph represents our AE model, also known as the Keynesian cross. We can see on this graph that with an output level of $500 billion, aggregate expenditure equals total output. This is a short-run equilibrium, where the economy is at full employment. Imagine that the equilibrium is reached at $400 billion, with the economy in a recession. This means that the full employment output level exceeds $400 billion. In this case, the full employment output is $500 billion. There is an output gap of $100 billion. We call this a recessionary output gap. A recessionary output gap means the expenditure level in the economy is much lower than where it should be. The difference between the current and the desired expenditure level needed to eliminate a recessionary output gap is called the expenditure gap. Definition of recessionary gap. The recessionary gap is the difference between the current level of expenditures in the economy and the level of expenditures needed to reach the full employment level of output, when the current output level is below full employment. Inflationary gap. Imagine our economy operating above full employment. On our graph, the current equilibrium level is at $540 billion. The full employment output is $500 billion. Thus, the output gap is negative $40 billion. We are producing $40 billion more output than desired. This causes a lot of problems, including high inflation. This typically happens during the expansion phase of the business cycle. During this phase, incomes rise, generating extra spending and pushing the economy above the full employment output level. The inflationary gap is the difference between the spending level needed for the economy to operate at full employment and the current level of spending with the economy operating above full employment. In the previous case, the output gap of $40 billion is also known as the inflationary output gap. This concludes our lecture on the aggregate expenditures model. Thank you for following this lecture. Dr. Jermaine Pishop.